let A be this set proposition supremum of the set is square root of 2. Okay, proof. Let supremum of the set be S. Now we have a key idea. First, we are going to show the following inequality. Okay, we have following. We need to show that. First, we need to show left hand side. So how are we going to do? It's 1 over n square 2. Okay, let's assume otherwise. We are going to do it proof by contradiction way. So let's assume 2 is bigger than 1 square. Okay, we know that S is the supremum of the set. So since sub A, for every positive real number there exists x0 in the set such that S minus 1 over n, I'm choosing epsilon to be 1 over n, less than x0. That implies if we square both sides, 1 over n square less than x0 square is less than 2, because x0 in the set and it should be satisfying this property. Yeah, but we have a contradiction because we have assumed that 2 is bigger than this, but this is less than 2, so 2 is bigger than this, and we have contradiction. Okay, we have managed to show first one. What about right hand side? S plus 1 over n square is bigger or equal to 2. Okay, we have several steps. First, okay, but we are going to assume otherwise. First, assume S 1 over n square less than 2. It is our main assumption. Now we have several steps. First, assume S is rational. Since S is rational, then S plus 1 over n is rational too. And since its square is less than 2, then plus 1 over n should be in this set because its square is less than 2. But we have contradiction because S was the supremum of the set, then S plus 1 over n should be less than S, but this is bigger than 0, so we have contradiction too. Now assume S is irrational. Define w to be greatest integer function of n plus 1 multiplied by s over n plus 1 plus 1 over n plus 1. Yeah, it's a little bit weird real number, but bear with me. Okay, we claim that. Now we have another claim. Claim s is less than w and w is less than s plus 1 over n. Proof. Okay, first left hand side. Now, using the definition of greatest integer function, we can write n plus 1 as less than greatest integer function of it plus 1. Okay, now divide both sides by n plus 1, then we get the desired result. So it was very easy. And what about right hand side? Now, following the same idea, let's write trivial inequality for greatest integer function. 1s less than plus 1s plus 1 over n, since it is positive. There is a strict inequality. Now let's add 1 to each side, so we have n plus 1 s plus 1, but we are using these two inequalities, we disregarding the middle one, so we have n plus 1, I'm just writing this, plus 1. If you add 1 to this side, you get n plus 1 over n. Now, just divide both sides by n plus 1, then we get the desired result 2 plus 1 over n plus 1 less than s plus 1 over n. So we proved both right hand side and left hand side. So how we are going to use it? So we assume that this doesn't hold. So assume s plus 1 over n square is less than 2. Then we assume s is also irrational, and we claim there's a some kind of real number which is also rational. So it is natural number, so we get rational number here. So we proved also an inequality that we are now going to use it. So just look at the inequality and just remember this inequality. So we have s plus 1 over n square less than 2, and we have v in rationals with says less than w less than plus 1 over n. So just square every side here. Sorry. Then using this inequality, so we get less than 2. Now, since w is rational and its square is less than 2, by the way, w is bigger than 0, is very obvious here. So we get contradiction because there is a rational number which is bigger than s by there. So it contradicts with the idea that sup a is s, but s should be bigger or equal to any element in the set, but we have contradiction contradiction. So we prove our main key idea here. I'm just going to copy paste it. Bear with me. So what is the point? So the point is, now by either using Square's theorem or some other techniques, you can prove that actually s square is equal to 2. Okay, I'm going to use limit way. I'm sorry. Yeah. Take limit when n goes to infinity, then by squeeze theorem from the calculus we get s square less or equal to 2 less or equal to s square. Then s square is 2. Then s is square root of 2, which was supremum of a. So we prove our idea.